we'll just wait a bit more, like
Sure.
another 1 or 2 minutes, because there are still folks in the lobby.
Okay.
Hey there, everyone. So it's time, and as almost a lot of you are up here, so without any further ado, a very good afternoon to one and all present here. Thank you so much for coming up on this Friday evening for such an amazing session by our speaker, it's Mr. Saurav Behra, who is an expert in this particular domain that he's going to present, that's machine learning. And really excited for all of you, as well as really excited to host this. So without any further ado, I would not take the stage anymore and ask the speaker of the day, Mr. Saurav Tehra, to come up on stage, give a brief round of introduction, and probably then we can start the whole session. But before he joins, three ground rules. If you want to discuss anything, kindly use the chat section. If you have any queries, please wait up till the session ends, and then you can use the chat section or unmute yourself and ask questions. And the last is, do not leave as soon as the speaker ends his session. We have a rapid fire round and something special after the rapid fire round for you. So stay connected for the next 1 hour with us. And over to you, Savripaya.
Uh, Good evening, everyone. Hello. Really excited to have you all on board for this session. Let me share my screen, and here it goes. So, okay. So, I hope my screen is visible to you all, guys. Ankita, can you please
Yep,
confirm?
it is.
Yeah, works. So, hi everyone. Welcome to the session getting started with machine learning. So here, this is going to be an introductory session to learning machine learning. Uh, Understanding the basic concepts of it, and then we'll also have a hands-on session. So before that, I would like you all guys to have use the chat section if you have any doubts in between, and I will be more than happy to answer you guys. I'll also have a Q&A round session maybe at the last, wherein I would like you guys to unmute, and if you have any queries, you can feel free to ask me your questions. So let's begin. So we'll quickly move on to, yeah. So we'll quickly first get into, just a minute. Yeah. I hope there's a slide not moving. Yeah. So we'll first get on to discuss the agenda of the discussion, or what will be the flow of the entire discussion. So first of all, we'll try to understand what is machine learning. Is this not a buzzword? But what does it actually mean? Is it a computer? Is it a humanoid, or something other than that? Next, we'll also understand the overview and its types, and then we'll also quickly get upon the list of prerequisites that are required for understanding machine learning concepts and the steps involved in various machine learning algorithms. Okay, and finally, the most important and the most exciting, we'll have a hands-on session. That would be a hello world in machine learning. So we'll build our first project in this session itself. So a brief about me. So hi, I am Saurabh Bera, a cloud solution architect at Microsoft, and also I'm the your GDSC AI/ML chapter lead. And I have been working on several machine learning models, right from machine learning projects, right from my first year. Then I have been steeply moving on to deep learning models. I had used throughout my career. I have been working upon multiple projects, building several models in different fields. I also take great interest in research. I have built my customized own deep learning model, which I have patented into a research paper. Along with that, I like to actually embed a machine learning model into a low computational device like mobiles or microcontrollers, so that they can work in a less compute environment. So this is all about me. So we'll quickly move on to what is machine learning. So isn't it a question that arises in everyone's head? So we'll first, before understanding what is machine learning, we'll first understand a quick history, or we'll get through a quick history of machine learning. So it was in 1950s that a buzzword artificial intelligence arose. You must remember this was the year wherein the first computer was also brought up to the market. And why these computers were built? This was basically to calculate or evaluate a particular thing in a better way than humans can do. At the same time, to replicate or build human-like features into computer. So within that particular era, the concept of artificial intelligence rose, wherein a lot of people were excited. It was not actually implemented, though a concept arose for building humanoid robots. Then in 1980s, machine learning came. So machine learning basically flourished for the next 30 years, and therein a lot of mathematical concepts like linear algebra, calculus, probability. You have the concepts of the statistics being and visualization, graph visualizations involved, and basically a lot of machine learning algorithms were innovated and researched upon. Then, in the year 2010, a concept of deep learning came into the market, wherein like a simulation of the human neurons of the central nervous system was simulated into a machine, into a model, wherein each neuron, as in a neuron, we have pulses passing through. Similarly, these kind of neural networks, we had neurons wherein data would be passing through. They would be they would be passing through some functions, and then it would be gradually calculated. So it was really a complex thing to understand, but yet the modern world works totally upon deep learning and machine learning algorithms. So we'll first understand what is machine learning. So machine learning can be understood as an algorithm that enables a computer to learn from data and even improve themselves without being explicitly programmed. And at the same time, why do we need data? We need to the program needs, or an algorithm needs a data to understand the particular trend, or particular use statistical analysis upon it, or particular observations or trends to actually predict output from that. Example for it would be, suppose if I give an example like this is a banana, so it has a yellow color, it has a particular length, and it is curved. At the same time, if given a mango, I will have again it has yellow color, but at this time it's not curved, neither it has the same width and the length as in case of a banana. So I would be able to explicitly define this is a banana and this is a mango. So here, machine learning uses a wide range of data to actually train themselves, and based upon the particular trends and observations, they come onto the output. They use statistics and calculus to predict the output of particular input data. So quickly understand what are the different types of machine learning. So basically, in machine learning, you have different algorithms, but a broad division of the entire machine learning would be in three categories, or maybe four categories itself. So there are supervised, there is unsupervised, and there's a reinforcement. There's also a semi-supervised learning. So we'll be quickly moving on to understanding these three categories of machine learning. So in supervised learning, what happens is that, as the name suggests, there is a supervisor, or there's a human sitting behind, or maybe a trainer sitting behind who actually trains the machine learning model. It gives the input data, it tells that this is of a particular label or it's of a particular classification, while the other data is of a particular label or a particular classification. And the machine learning as student, the machine learning algorithm as a student tries to learn up or understand or derive a particular observation or trend upon it and categorizes the output. So let's give an example, as you can see in the slides. So there are emails. There are a lot of emails coming to the inbox. Now, I set as a supervisor, label each of the mails as spam or not a spam. The computer tries to understand the content of the email. If it finds particular observations that these words are in a particular spam mail, it will try to regularize it and generalize a particular trend that are clearly observed in all of the spam mails. Now, when a new set of email arises in the inbox, now it will try to categorically separate whether it's a spam or it's not a spam upon those trends or observations. This is called supervised learning. Now, what is unsupervised learning? As I spoke before, that in supervised learning we have labeled data set, or we explicitly define labels or classification upon the data set. Contrary to that, we have unsupervised learning, wherein we have data, we have a lot of data, but they are not actually labeled or categorically separated from each other. When it's fed to the machine learning algorithm, it does not have any kind of particular separation or labeling upon the data that a particular data is of this type or a particular data is of that type, but rather the algorithm uses artificial intelligence to understand a particular trend or observe a particular trend pattern, or maybe a particular set of observations that helps the algorithm to categorically define or have a bordering among the particular set of data. Over here, taking an example, as you can see in the slides. So we have a particular set of animation of characters. Now, we see there is a mouse, there is a duck, there is again a tucklin, and there's a rabbit, and there's again a duck. So now, upon ducks, we can see that there's a regular trend. They have a beak, isn't it? And even we can also see there are particular trends that they have kind of a tail at the back. Okay, now the shape of the tail might differ from a mouse or a rabbit, isn't it? So what the machine learning algorithm does is that, so its intelligence, it tries to understand a particular trend. If it has a beak with a yellow color or maybe a long beak, then it's a duck. Otherwise, it's something else. It doesn't matter to me what the other part may be. I would just label it as a duck or not a duck, as in case. So similarly, if you have a set of fruits within it, we can easily find a banana. We can easily understand what is a mango. So this is actually a simulation of how humans interpret things, isn't it? Now, I just need to change. This is a error. Basically, we now come to the reinforcement learning. So in reinforcement learning, what we do is that we have the algorithm or agent working over here. So basically, the steps involved are: observe. First, we try to understand what is the current setup done. So as in case of the example, we see there is a tap, there is a bucket, and there's a fire that is lit upon somewhere, some other place. Now, the agent has to just bring down the fire. What it should do first? Should it move first to the it? This reinforcement learning totally works upon a, a reward or a penalty, like a human kid does. So basically, if the agent works in the appropriate way or in an assigned way, it is rewarded. Or if it moves in a wrong way, it's penalized. Based upon those previous past experiences, it learns what to do next. And the more it is trained, the more it becomes better. So, or here given an example, this is really a good example wherein a reinforcement learning works. So we have an agent and the fire is lit. The agent should is confused whether to move in the direction of the fire or whether to move in to the tap to get the water. If the agent moves towards the fire, which is obviously a wrong step, it is penalized with a 50 with minus 50 points, and the agent itself learns that this is a wrong step, and in the future steps it would avoid this step. Rather, now it will understand that this was a bad step. Now I need to move to the other direction, that is towards the tap, fill in the water, and then bring down the fire. This is the way reinforcement learning works, and you must have seen this reinforcement learning working upon multiple things these days in real world. Reinforcement learning is widely used in game space algorithms, in any games that you use, or in even in the Tesla car that is automated for moving onto the real world streets. So now we try to understand, so how can I understand a machine learning and what are the steps involved. So we'll quickly understand the prerequisites to understanding machine learning. Machine learning, indeed, it's not just about understanding a particular how a machine learning algorithm works. Rather, breaking down the entire algorithm into mathematics, trying to understand how a particular a result or an output is derived from the input. So the key things which are required for a person to understand machine learning are statistics for basic visualization of the data, as well as trying to understand the data set. When we have a large amount of data set, we do face a lot of issues in understanding what kind of data set is it. Is it a categorical data? Is it a labeled data? Is it unlabeled data? We apply statistics to understand various types of transforms that can be applied upon it. We also use linear algebra to derive a particular expression. Maybe it can be a simpler function like y equals ax plus b, indeed, or maybe it can be a complex function. So we use linear algebra concepts widely in machine learning to derive a particular output from an input. We also use calculus. So basically giving an example, if you are in your first year, then you would particularly understand. So if we have a graph like this and we try to understand how the slope is moving, is the graph totally increasing, or it is a decreasing graph? What is slope? What is the gradient into it? So we try to use gradient descent over here to understand where the graph would be moving. So basically, the gradient descent algorithm is widely used in machine learning. Next comes probability. So given a set of probable outcomes, predicting what is the opportunity cost, or what is the probability of particular outcome to happen, is what we leverage here. And definitely a programming language like maybe R, Python, which has a lot of inbuilt functions for machine learning. You can also use Java and C++ for machine learning as well. But isn't it a lot overwhelming to understand, to learn of these concepts, and then trying to understand machine learning? No worries. We have a lot of inbuilt functions built into Python and as well as R. So to help you out understand, which have an inbuilt function built into it, wherein you don't have to understand the interior working of function of a machine learning algorithm. Rather, you can use those functions to leverage the output from an input. So we'll now try to understand the steps involved in machine learning. First is the very important step. We need a lot of data. The entire machine learning model is built upon is actually trained upon a lot of data, a huge set of data. So it's the collection of the proper data set is a huge task that is involved while machine learning. Then involves then the next second step would be the visualization and the pre-processing of the data set. When a data set is given to us, it might contain a lot of noise. It might also contain several null values as well as a lot of outliers. By outliers, what I mean is that a particular data or an instance of data that is not actually associated with the particular input type. So we need to eradicate those outliers while training our machine learning model. Next comes the third step: choosing a suitable model for training. And for training, there are a lot of algorithms, like there is linear regression, there is multilinear regression, there is k nearest neighbor, there are SVMs, there is a lot of machine learning algorithms. But what to choose? We totally understand which algorithm to choose for a particular use case upon the data set as well as the use case. So a background knowledge of what kind of machine learning we are building is really required in data science and machine learning. Then training the model. Obviously, once the model is trained, we evaluate the model upon several metrics. The metrics here can be accuracy, there will be precision, there will be recall, there will be F1 score. So there are a lot of metrics. We'll understand these in a later session. There is also an important step: parameter tuning. Now try to understand, if you are given a test, okay, and you have a set of questions, you try to answer all the questions given. Suppose you're not able to answer a particular set of questions. You look back into your textbook after the examination, you find the answers. Now if you are given to rewrite your examination, will you not perform well in the examination? Much better than the earlier, right? Similarly, in parameter tuning, once the results of the machine and of the training takes place, we have the accuracies in our hand. Now we try to understand how can we make the machine learning model better. We try to tune the parameters again. We try to again rebuild the model, and the built model again would be a better one than the previous. And finally, making prediction is an obvious step for a machine learning model. Yeah. So now comes the time to get our hand dirty upon building us the first machine learning project. That will be a Hello World machine learning project. Okay, so I would quickly request you all to use this link to open Kaggle. So just give me a minute. I'm sharing the link to you on Teams. Okay. Yeah. I'm sharing the link on the chat. You need to have your laptops with you handy, and you can just open the link via your web browser. Let me know if you're done with a yes, so that I can move on with it. Good. So once you're done, you need there will be a sign out section. There will be a login and sign up section. In my case, I've already signed in, so you can either click on register or sign in. So you need to click on register, and you can register via your email, or you can also use your Gmail authorization. So or Gmail or authorization, directly register via Google. Once you're done with this, so in my case, since I'm already registered, I'll use my credentials to sign in. Okay, good. So over here, you can click on, if you see this notebook, you can easily click upon copy and edit. If you see this option, let me show you. Yeah, so you can just click on copy and edit. This will create a copy of this notebook onto your instance. So in Kaggle, this is a platform. Let me explain it to you. So this is an inbuilt platform for data scientists and machine learning enthusiasts, wherein it provides an inbuilt environment, Python environment, basically Python 3 or Python 2 itself, and it has all the Python modules inbuilt into it. So basically, we can use this inbuilt environment to create machine learning models as well as try out different data sets. So Kaggle hosts a lot of data sets. It is the largest platform in the globally to host data sets. So there is a lot of competitions that takes place upon these data sets. And we'll be using the simplest of all, the iris dataset for today's session. If you have already signed up, let me know in the chat section. Okay, so Ashutosh has done. Okay, and we'll quickly now we'll have a quick over while you sign up. I will have a quick overview of the dataset. So the dataset we are using over here is the iris dataset, which is stored in a single CSV file. So basically, what this data set means is that we'll be predicting a particular set of flowers, which is Iris setosa, Iris versicolor, and Iris. Just give me a minute. Yeah, Iris virginica in this case. So we have three flowers, and how are we categorizing those? These are our features, basically sepal length, sepal width. Uh, okay, just let me refresh. Yeah, so we have sepal length, sepal width, petal length, and petal width. I guess a lot of you might be having issue with understanding these things. No worries. This is the first session, so it would be quite overwhelming. I understand, but with the upcoming sessions, you will get used to it. So, what are these sepals and petal lengths actually? We'll try visualizing it first. So this is basically iris versicolor, which is a part of our flower that we'll be predicting. So we are categorizing these flowers upon a particular trends. So we have seen a trend that a sepal length. This is the sepal length, and this is a sepal width. Similarly, we have a petal, which has a petal length, a petal width, and a petal length. So upon these parameters, we are predicting what kind of flower it might be. So you can see there's a visualization provided. So you have three unique values. This is basically a label data set because you see with the input data, you have a label as well, which is iris setosa, iris versicolor, iris virginica over here. And also you have a visualization of different data. So you can easily see that the sepal length is within the range of 4.3 to 7.9. Sepal width is within the range of 2 to 4.4, and similarly goes on. Okay, so we'll quickly move on to the notebook, and we'll click on edit. In your case, you have already created a copy, I guess, and we are good to go with this notebook. So now we'll try understanding how can we run this notebook. So I have already filled this notebook with the codes so that it's easier for you to understand. And we will be walking through this code to understand what it is actually doing. So it's written in Python 3, and we use enter and shift. Okay. Run enter and shift to run the code. Oh my God. Let me know just if I'm audible to you, Ankita.
Yes.
You're audible. I guess I'm audible, right? Yeah.
Yes, you
So,
are.
hmm. Okay. So now we can use either control as shift and enter to run the module, or you can also use this key to run a cell. Okay. You can also use this run all for running the entire set of notebook. But before that, I would request you all to just have patience so that I can explain you the lines of code. So anything that in Python, anything that starts that is followed by a hash symbol is a comment. And we very well know that comments are not compiled. It's just for the easyability of reading a particular code or understanding a particular code. So we'll straightforward come to the code section. That is, we have import NumPy as MP. Basically, NumPy is a module in Python which is used for dealing with dealing with arrays. It has inbuilt functions that could easily help us implement and work with multi-dimensional arrays, nearly four-dimensional arrays or nth dimensional arrays, and also it has inbuilt functions to implement linear algebra functions like equality and distance, and much more. Okay, and then we have import pandas as PD. So pandas is a Python library which is built upon top of NumPy itself, and it is used for actually dealing with a data set, or more precisely a data frame, or you can also use it for a wide variety of purposes, like as I already mentioned, for linear algebra functions you can use pandas. Okay, or you can also use it for data visualization as well. Then we have import OS. So OS is an inbuilt function in Python which is actually used to get a reference of particular directory in your system, or you can also use it to create a particular directory, remove a directory, change the content of the directory as well. Okay, now we have a for function. So for dir name uh, underscore file name in os.walk kaggle input. So kaggle input is our directory over here. What we are doing is that within the input directory, we are trying to fetch all the directory names and the file names. So for file name, in file names, print os.path.join. This is the inbuilt function os.path.join. The join function takes two parameters, directory name and the file name, and joins both of them. So we are just printing the directory name plus file name. So here it contains the input directory contains only a single directory, that is iris flower dataset, and within that we have a single file name called iris.csv, right? This iris.csv is our data set. Now we need to read the data set. How will we read our data set? It will be done via pandas. Okay. Before that, we'll use import a cbond, which is a library in Python, to actually have a great visualization. It provides a great visualization interfaces. It is built upon top of matplotlib, which is also a data visualization platform. Basically, we built a lot of graphical interfaces, or a lot of graphs via this matplotlib or cbond. Okay, so cbond is an advanced version of matplotlib which provides many functions other than that, and it supports multi-dimensional visualization as well. So now, first we'll have we'll read the entire data set via this function, pandas.read csv. We'll store the data that is read from this CSV file into a data frame, which is DF, and we will be referencing this data frame throughout our program. You can just run each of the cell via enter and shift. Okay, so I have the second cell running. Now I'll run the cell as well. Now we use the head function. What is head function is used? The head function is widely used in data science to actually visualize a data set. Okay, how do we visualize our data set? Just give me a minute. It's running. Let me just, I'll have some time. Let it run. Okay, DF is not defined, so I guess the first cells are not running. Let us run it. Now it should work. Yeah. See, basically, what the head function does is that it returns the first five rows of the data set with all of the attributes. So over here we have attribute as sepal length, sepal width, petal width, which we have already discussed, and the label, that is species. Okay. Now we'll try to understand what is the length of our data set. We'll use the info function. So it after running, we get the output that the entire data set has 150 entries ranging from 0 to 149, and then for each column we have each column we have 150 entries of particular type float 64. Okay, which is a numerical type and we require it. We also get to know whether a particular attribute is null or non-null. Okay, so every over here, all the classes or features are not null. Okay, suppose we also need to do a cross validation whether all the features are not null. If a particular category of the data is null, then we'll have to remove it. So we use this is null function to check whether a particular feature is null or not. And if it's null, we'll remove it in the further steps. But over here, we can easily see that sepal length has zero null attributes. Similarly, sepal width has zero null attributes, and so on. Okay, and species over here is a categorical labeling of the data. Now we'll use a describe function to get more insights upon our data. Okay, so basically this describe function uses statistics to give a reference into our give an insight upon our data set. So this is a part of the data visualization. So over here we have the count of the sepal length, that is 150, as you can see, for all of the data. And then we also have the mean of all of the values that data for a particular feature. And we have the standard deviation. So I guess all of you understand the mean. What's mean? Now we will try to understand what is standard deviation. So basically, standard deviation is the deviation from the deviation of a particular instance of a data from the mean. Okay, so we take the average of all the deviations of the data, and this is the standard deviation. Okay, now we also have the minimum value that exists for a particular attribute, that is 4.30 in sepal length, 2.0 in sepal width, and so on. We have this 25%, 50%, and 75%. This is really important to understand. So basically, what 25%, we have quartiles in data science where we visualize data. So this is the first quartile, which is like how many values are within the range of 0 to 25% of the total value. Okay, this comes into the first quartile. Similarly, there's second quartile, there's third quartile, and finally we have max, which actually stores the which actually represents the maximum value that's stored in the particular feature. Now we'll try to understand what how many unique labels are contained within our species. Okay, so since the species is a label, we've tried to understand how many unique categories are there. So basically, as we have already discussed, so there is Iris setosa, there's Iris versicolor, and Iris virginica. For each of the type, there are multiple dataset instances. Okay, now now comes the visualization of the data set. Okay, so we'll try to understand if there is any certain particular trend or observation that could be derived from the data set. Okay, so over here we try to draw a scatter plot upon it. Scatter plots are basically points on the graph, or a two-dimensional or the three-dimensional graph, and each point refers a particular data instance. Okay, so over here, we in the x axis we take sepal width, and in the y axis we take sepal length. We also take the legend or hue over here as the categorization as species, which is the label of our data set, and data obviously as the data frame. Okay, which we have already stored over here. The pandas read CSV. We have already stored the data frame into the variable df. So we'll run this cell, and you can see there is a regular trend for Iris setosa, which is already labeled over here. Do you see a particular trend? Is it can we draw a particular boundary upon these data points upon the scatter plot to categorize these data? Yes, we can. See, if I draw a particular circle on the Iris setosa, it is easily distinguishable from the other data set. At the same time, if I try to draw a particular circle on the Iris versicolor, that is yellow color, and Iris virginica, which is green color over here, am I able to distinguish? Am I able to distinguish between them? No, there's overlapping. Then we'll try to understand by a petal length. We'll also categorize these data on a scatter plot via petal length. Okay, so we'll just make a minor change, and we'll again rerun it. Now see, this iris setosa is quite apart from the other two. But now using the petal length and petal width as a feature, we can easily draw a circle on the both of the flowers. Okay, so there's it's a distinguishable. We can draw a boundary of or of a difference between them. So the main intuition while drawing the scatter plot is to actually trying to understand that we can distinguish between the data between the flowers based upon the data provided. Okay, and over here, as per the intuition, we use k nearest neighbor algorithm to actually distinguish the data, since we can easily draw a boundary of distinguishing between the particular data points on the scatter plot. Okay, now what we do is that for training and testing, we use only numerical data. So over here, as you see, we have the sepal length, sepal width, petal width as our numerical data set. Okay, but the species is just a label. So we won't feed it into the machine learning model. Rather, we'll keep it for checking whether the machine learning model is able to predict the same thing that is expected out of it. Okay, or while as well while during the testing. So first, what we'll do is that we'll segregate the labels into a particular variable y, and we'll have all the numerical data into a particular variable x. Okay, so x will store the data frame of this much of data: the sepal length, sepal width, petal width, and y will store this labels. Okay, simply. Now we'll import like a function from sklearn library, which contains a lot of machine learning libraries. Okay, algorithms, functions inbuilt. So we use train test split to split our data. Now, as I already mentioned, that both training and testing is an important phase in our machine learning algorithms. Okay, so we actually need to have a separate set of data for training and testing. So what we do is that we split the data into two parts. That is in the ratio of 8:2. That is 80% of the data is goes to the training the model, and 20% of data is used for testing. So over here we use test size is 0.2. That is 20% of the data goes for testing. At the same time, we use randomized state equals 3 to randomize data for a better training, so that the model does not get overfitted. Now we'll import our algorithm, the function that uses the algorithm. So here, as we have already discussed upon the intuition, that we'll be using the k nearest neighbor. So we'll import from sklearn.neighbors, import k nearest neighbor, and we train them. We create an instance of the k nearest neighbor over here, which is stored in the model. So model k nearest neighbor, and we set the parameter of nearest neighbor equals 1 over here. Okay, now comes a major step, which is training our model. So we use the fit function to provide the training data set, that is x train and y train as in case, and we use the fit function to train our model. So we use model.fit x train comma y train. So our model has been like trained upon the model. Now we use now do we need to have a prediction? But before prediction, we need to understand how precise or how accurate our model is. That is a validation of the model. So now we'll validate our model, and we use the score function to test the model upon the training testing data set. If it we have already trained used the model to train our the training data set to train our model. Now we'll use the testing data set to test our model. So we use model.score x test y test, and we get an accuracy of 93% over here. You can see, right? So now we have a testing. We have already tested. We have also already got the accuracy of the model. Now, don't we need to predict a prediction from our model? So we'll use the predict function over here to test a particular output. So we'll use model.predict x test to test our model. So you can see we have inputted the numerical data x test, and it gives an output of this, which is the prediction of the model. Now we'll compare whether y test and x test is same or not. So we'll print y test.
My apologies for interrupting. We just hit the exact
Sure.
time slot, but we could,
Exactly.
take up like 2 to 3 more minutes
Yeah.
so that you could
I'm
wind
just
it up.
done with it. So I've just printed the test data set. Okay, the labels of the test data set, and you can pretty much compare in your free time that most of the prediction that by the model is similar, because we have a great accuracy over here, 93%, which is a great accuracy indeed to be used in a real time. So this is how we actually predict our we built our first machine learning model, that is Clark classification via iris dataset. So with this, I just give a minute. Yeah. So with this, we come to the end of the session. I'm open to any question if you have, and I would be more than happy to answer it. Yeah. Guys, you can unmute yourself if you have any question, or you can use also the chat section to ask me any question if you have particular, or else we can wind up the session. I guess it was quite overwhelming for you guys at the first instance to understand it, because I pretty much understand machine learning is not a thing to be understood in a single day. Rather, it takes months and years to understand. And I'm pretty much sure that if you are consistent enough to practice it and get also consistent to join the sessions, henceforth for machine learning, you will be able to get much more from it. So, is there any questions? We'll be doing more such sessions. Yeah, indeed, Ashutosh, we'll have much more sessions like this. And since you have, you can use this notebook to actually rerun it, build your first machine learning model, store it within your Kaggle account, and you can also try and test many other machine learning models. If possible, I will provide reference to those in the Telegram group. And yeah, definitely you will get more idea upon it. Even you will have hands-on sessions much more than this. If there's no more questions, Ankita, I guess you can move on with the rapid fire question. Okay, resource to learn basic math. Okay, Mayank, so yeah, indeed, you need some resource to, so you can use towards data science, and you have analytics Vidya as well. So I'll just post in the link to those in the Telegram group if required, or else I can do it itself over here while Ankita poses rapid fire questions. So you can use this website. This is really helpful to understand the mathematics as well as intuition of why we are using a particular type of machine learning model. And you can also use this one. Oh,
Sorry for the interruption again. And you all can access the chat right now so that you have the rapid fire round link.
yeah. So by then, Ankita, can you just move on with the rapid fire question? Because
They're already there in the chat. I've
okay,
notified them about it. So
great.
feel free, the stage is yours for the next 2 minutes, and then the meet will automatically shut down.
Guys, no worries if you miss the links over here. I'll just put on every link and with all the resource in the Telegram group itself. So no worries with that, and even in the Discord. So pretty much done with it. It was really great having you all guys over here, spending 1 hour over here and discussing upon the introduction to machine learning. See you. Bye bye, guys.
Thank you so much again, everyone. Thank you so much, Saurav, for hopping in, giving us your time. Thank you, everyone, for coming up this Friday evening and being here. A quick notice for all of you. So, apart from just these sessions, pretty quickly, we are going to come up with some challenge rounds. And then, because it's GDSC, so we're going to come up with some Google programs in machine learning itself pretty soon so that you can contribute over a period of time and earn swags as well. So, stay tuned on the Discord server and on our socials, and pretty in the very near future, like probably in the next month, you'll get notifications about more such events, more such opportunities. So thank you so much again for hopping in, and I hope all of you have a great day ahead. Take care and have a great evening.